In this video, we're going to talk about organizing data. We're going to go back to that same data set that we looked at earlier, and we're going to look at a few different ways to organize our data. Now, to keep things a little bit on the simple side, I've chosen to look at the age data, and I'm going to use just these values here. You don't need to copy them down. I'm going to go ahead and just, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I'm going to go ahead and use those 14 data values. To review what we saw in Chapter 1, let's go ahead and start with the fact that we're using the variable age. Age is, because it's a meaningful number that we're assigning to that variable, it is a quantity, so it's a quantitative variable. Quantitative. It's continuous because every second I'm getting older, right? I'm a second older now, and now I'm another second older, and now I'm another second older, which is really depressing, but it's a continuous variable. However, if you look at the data here, especially when you're grown up, you don't give your age in a continuous form. I don't say I'm 24 years old and 38 days and 52 seconds or whatever it happens to be. We just round it off. So it looks discrete, and it can be treated either as a discrete or a continuous variable, but really it is continuous. Okay, so quantitative. I missed an N, didn't I? So that's quantitative and continuous. We're going to start by putting together a frequency distribution, so B. So the frequency distribution has some vocabulary terms in it right off the bat here. A distribution, we use this word a lot in statistics. It is just a list of data. And frequency is just the amount, right, or the number of times a certain data value happens. Amount or quantity. And we're actually going to be doing a grouped frequency distribution. So we're going to take this age data and we're going to put it into groups. And I've chosen to use 4 classes. So for 4 classes or 4 age categories, you know, between 18 and 30 or whatever it happens to be, we're going to use 4 classes of data, and we're going to start by figuring out what the class width is so that we can organize our data really nicely. So I need to figure out what the maximum and the minimum data value is for the data that I've chosen. And I go through here and I see that the highest data value, they're right together, there is 16, and the lowest data value is 18. So my maximum is 68, my minimum is 18, and if I subtract those two, I get the range. 68 minus 18 is 50. Well, I want 4 of these classes. So I take 50 and I divide it by 4, and of course you can do this on your calculator. So we get 40, oops, not 4, it goes in there 12 times, right? So 12 times 48, subtract, I get 2, give myself another 0, so I get 12.5. It doesn't matter what I was going to get here. I know I was going to round up, because if I round down, I'm not going to include all of the values between 18 and 68. So I always round up, which means that I want to use a class width of 13. So I'm going to go ahead and build this. I'm going to start with my class limits, and that would be between this age and this age, so class limits. My lowest age is 18, but I'm not going to add 13 to get this value here. I'm going to add 13 to get the next value, so plus 13, the next lower value. So 18 plus 13 is 31. And you can see then that this value here must have been 30. So I'm really using my variable when I do my class limits as a discrete variable. Okay, now I want 13 between one minimum to the next, so that gives me 18 to 31. But I need to put the last value, which would be 30 in that first class. Okay, so continuing on like this, 31 plus 13 is 44. So that would be 43 as the max over here, the upper value. Lower value 44. 44 plus 13 is 57, so that would give me 56 here. Notice that I'm adding 13 over here as well, so I can do either the lower values or the upper values. And so I know then that my last value here is 69, and notice how nicely that includes my maximum and minimum values. So those are my class limits. I'm going to next put together my class boundaries. For the class boundaries, we take what we've expressed as a discrete variable, 18 to 30, and then I skip to the next age, which is 31, and I change it into the continuous variable that it really is, continuous, which means I want these two values to be the same. I want them to touch. So I'm going to do the 0.5 adjustment. So I'm going to take 18, and I'm going to round it, well, I'm going to adjust it 0.5 down. So 17.5 to, I'm going to adjust the 30 up, so to 30.5. So when I do my class boundaries, I want to do minus 0.5 to my lower values, and I'm going to add 0.5 to my upper values, and that gives me my class boundaries. Okay, so I'm doing my 0.5 adjustment. These are going to match now. 30.5 butts up against 30.5. 43 becomes 43.5, and I'm going to repeat 43.5 again. 56 becomes 56.5. And then 56.5 to 69 becomes 69.5. Okay, so I've got my class limits, and you can see how I've expressed those as a discrete variable. The class boundaries, I bumped them out, so I've expressed those as a continuous variable. Okay, last but not least in my list here is the frequency. I went ahead and took the time before I recorded this video to run through and count up how many values I had between 17.5 and 30.5, or similarly between 18 and 30. So I went ahead and counted each of those up, and I'm going to give those to you now. Okay, so between 18 and 30, there were 6 data values. Between 31 and 43, which would be 30.5 and 43.5, I had 5. In the next class, I had 1, and in the last class, I had 2. If I add these numbers up, this is the summation symbol. Summation. It is a capital sigma. And if that seems Greek to you, then it's because it is. So that's the Greek letter sigma. If I add these up, I get 6 plus 5 plus 1 plus 2, which is 14. I don't know if you remember, but at the very beginning of the video, I highlighted these. I counted how many I had, and I had 14. So that should match the total number of values you've got. It's a nice way to double check that you've got everybody. Okay, so what we're looking at is the grouped frequency distribution. You can see that I've got everything listed. All 14 of my values are included. It's grouped because I've grouped these in classes, which are my age categories, and I did it discretely with the whole numbers and the limits, and then with the boundaries, I did that with the 0.5 adjustment. We're going to go ahead and take this data and do a histogram. So C is the histogram. And we're going to use the class boundaries for the histogram and the frequencies. I'm going to put this on. Oh, actually, you know what? I'm not going to. I'm just going to do it by hand. I was going to use graph paper, but I'll just do it by hand. You can do the same. There's lots of fancy ways to do histograms. Your graphing calculator will do it. I don't think it's worth it, personally. As I construct my histogram, I'm going to put my class boundaries along the vertical axis. So these describe my ages. So I need 1, 2, 3, 4, 5 cutoffs. 1, 2, 3, 4, 5 cutoffs. So this would be 17.5, 30.5. It's really important that I'm using the class boundaries with the 0.5 adjustment because a histogram has the bars touching. Here is my frequency. So my frequency goes up to 6. So 1, 2, 3, 4, 5, 6. So that would be 6. 1, 2, 3. And then I go ahead and just construct my bars. So 17.5 to 30.5 was 6. These are just too easy to do by hand, especially with the number of classes that you'll be working with. And then 5 is the height of the next one. See how my bars are touching. And then 1. And then, oh, this was supposed to be 56, not 46.5. So 43.5 to 56.5, and then 56.5 to 69.5 is 2. So there's my histogram. You can see that my peak happens to be here. So my peak is in that first class, but the rest of my data, all of the rest of my data, is to the right of it. We call this histogram right skewed, because most of the bars are to the right of the peak. If I were to have a histogram where the peak was, wherever it happened to be here, where the peak was here and the majority of the bars were on the left, I would call this left skewed. We also call these, so right skewed would be positively skewed. Thinking of the positive as the right and the negative as the left, which means left skewed would also be negatively skewed. And then we also have, so one more, so there's my peak with the majority of the bars on the left or the negative side. We could also have one where the peak was in the middle and my bars were pretty evenly distributed on either side. And this one is bell-shaped. We're going to be working with this a lot. Oops, that's a D. Come chapter 6. So my bell shape, ooh, that's pretty nice. So my bell shape would look something like that. So that one is bell-shaped. So that's the histogram, but make sure that you're using class boundaries and that you're also able to label. My F looks like the end of histogram, but it really isn't. It's the label for the vertical axis. You're able to properly identify the values on the vertical and the horizontal axis. So that's the histogram. The last thing we're going to do with this particular data set is part D, which is the stem and leaf plot. Oops, I cannot spell today. Okay, the stem and leaf plot, which is kind of a histogram on its side, but I'm just going to use the numbers. So let's see if I can get all 14 of my data values correctly here. I'm going to use age again, so this is for age. So I'm going to go ahead and use age, but I'm going to go ahead and put the tens values on this side, and remember I was as low as 18, so I had the teens, 20s, 30s, 40s, 50s, and 60s. And then I'm going to put the ones on the other side. So for example, remember I had an age of 18 and I had an age of 19. Those were my only teens. So I would make sure that these were in order and then record an 8 and a 9. Okay, no guarantee I'm going to get all 14 of these because I'm going to do it kind of quickly. For my 20s, I have a 24, a 26, a 21, and a 25. So I'm going to put these into my, move this up so you can see, I'm going to put these into my stem and leaf plot in order. So 1, 4, 5, 6. 1, 4, 5, 6. Notice how I lined it up with the 1 and the 9. So I can see that I've got twice as many people in their 20s as in their teens, just at a glance. Okay, now for the 30s. I have a 32, I have another 32, a 36, a 37. Okay, so same number of people in the 30s. Oh, they're already in order. So 2, 2, 6, 7. For the 40s, I have the 40s, just one person in their that is 40. So I put a 0 there. I do include the 0 because that is an age. And then 50s, I still have room. So for the 50s, I've got 50. And that's all again, so 1 0 there. And then for the 60s, I had 65 and 68. Those are in order, so I've got 5 and 8. This is all you do for the stem and leaf plot, but you can see that it's sort of a histogram on its side. I can quickly see that I've got the majority of these participants between their 20s and 30s. And I do have a significant number of participants in their 60s. So it's kind of like a histogram on its side. Okay, so that's the stem and leaf plot. There are several other displays of data. I'm just for this video going to do the scatter plot to finish off. But know that there's also, in case you come across it, go ahead and check in your book and read about it. There's the frequency distribution. There is the ogive, which is like a grouped frequency distribution. Oh no, a cumulative frequency distribution. It's the grouped, that's true, but it's cumulative frequency distribution. Maybe we will do those actually. It would take me just a minute. Let's do it. So let's do A, B, C, D, E. Okay, so for E, let's go ahead and do the frequency distribution as a graph is the frequency polygon. And the reason I said let's go ahead and do it is because it's really, really easy once you have your histogram done. So if I go back to my histogram, the frequency polygon just sits right on top of my histogram, and it grabs midpoints and connects the midpoints. So it looks like this. So if I were to pick that up, though, and plot it on its own graph, so I have age here and frequency here. I need one more calculation, and what I need is the value that lives right here, which is my midpoint. So I need to figure out what those midpoints are. The midpoint is just the average of the upper and lower values. So it is lower plus upper divided by 2. So for that first one, it would be 17.5 plus 30.5 divided by 2. If I add those together, I get 48, which gives me a value of 24. So this midpoint, move it back over right here, is at 24. Okay, so this is at 24. Now remember, each of my classes, it had a width of 13, so these should be 13 apart. But let me do one more calculation, number 2. Let's do the next one, 30.5 plus 43.5 divided by 2. And if I add those together, I get 74 divided by 2, which is 37. That would be the next midpoint. That is this guy right here, 37. They're 13 apart, right? So I don't need to calculate all of them. This one then would be 50. And then 50 plus 13 is 63. So those are my midpoints. I'm going to go ahead and record those. So 24, 37, 50, and 63. And then my same frequencies, 1, 2, 3, 4, 5, 6. So 6 on the 24. I'm just redrawing what I had in red. And then 5 on the next one for 37. 50 was at 1. And 63 was at 2. And I connect the dots. So that is my frequency polygon. Frequency polygon. And then we have the ogive, A, B, C, D, E, F. The ogive, I like to think of it as the cumulative. I'm just going to write F for frequency, frequency polygon. Polygon. So as I do my cumulative frequency polygon, I am going to go back to my original list here, and I'm going to add one more category. I'm going to add it right here, F sub C. And that's my cumulative frequencies. So for all of my ages up to an age of 30.5, I have 6 participants. For all of my ages now, which is all of these two together, up to 43.5. So how many participants were up to 43.5? 11 of them. Now if I want everybody up to the age of 56.5, that's just one more participant. That would be 12. I better end at 14, right? So now if I include everybody who is up to an age of 69.5, I add those last two, and there are 14 of those. When I do the frequencies, I'm going up to these values. I'm going up to those upper limits. So that's what I plot in my ogive. So on the ogive, I take those values. So I take the 30.5. Actually, I'm going to I start with the 17.5. I give myself a starting place. And 17.5, that first value, remember we did that 0.5 adjustment, always has 0. So I'm showing how I'm accumulating now my participants. And now I go ahead and just put in those boundaries, 30.5, 43.5, 56.5, and 69.5. These are still representing ages. But now along my vertical axis, I'm representing not frequencies, but cumulative frequencies. So up to, let's see, how far do I go? 14, 2, 4, 6, 8, 10, 2, 4. So that's 10, that's 14, 2, 4, 6. Okay, so up to 30.5, we've got 6 people. I'm going to add on another 5. So up to 43.5, we had 11, which is about right here. And then 12, which was here. And then 14. So is that about 14? Oh, it looks kind of curved, doesn't it? But I go ahead and connect the dots, even though it looks curved. And that's my ogive. So I start at the lowest boundary, and then I plot all of those values on the upper boundary. So it's a little bit different than the last one. Gosh, we're doing great. So we got in the frequency polygon and the ogive. The very last display of data that we're going to look at in this chapter is a scatterplot. A scatterplot compares 2 variables. All of the displays we've done so far, variables, have dealt with just a single variable. So I'm going to go ahead and just grab some data off of this data sheet that I've got. I'm not going to grab all 14, but I had the 24-year-old weighed 112, the 32-year-old weighed 115, the 50-year-old weighed 173, the 26-year-old weighed 181. Let's see, I missed something. Let's see. Oh, this was 112. That's what I missed. Okay, this was 112. That was the 26-year-old. And then the 40-year-old was 130. 40-year-old was 130. Okay, so it looks like there might be a relationship between age and weight. And there's way more data than this, so I'm just going to kind of ballpark it here. But to do a scatter plot, I put one variable on the horizontal axis and the other on the vertical axis. It really doesn't matter, it's up to you. But when you go through your homework and your quizzes, it will tell you. Lowest value is 24 up to 50. So let's go ahead and do these in 5s, starting with 25. So 25, 30, 35, 40, 45, 50. So 25, 35, 45. And then my weights range from 112 to 173. So let's start at 110 and go up to 180. So 10, 20, 30, 40, 50, 60, 70, 80. That would be 180. It's going to be the trickiest part, so that would be 130. 30, 40, 150. Just label a couple there so you can see what it looks like. And I'm going to go ahead and create the scatter plot. What I'm doing is I'm matching these up like an ordered pair. So 24 goes with 112, which is about right here. So there's my first point. 32, that was 30, so 32 is about right here. It goes with 115. So 115 was a little bit bigger than that. Remember, this is 10, 20, so a little bit bigger there. And then 50 goes with 173. This was 170, so a little bit more would be 173. 26, okay, back over here, 26 goes with 112. Lines up with that one. And then 40, which is here, goes with 130. So this is my scatter plot, and it looks like there's a relationship. I would really need to graph some more data to figure out if there was one. In this class, we only look for linear relationships. It actually looks like it's kind of exponential, which is interesting, just based on what I chose. But it does look like, if I were to just kind of ballpark a line, that would be kind of close to all my points. That's not bad. It looks like I would end up with a positive line. So it looks like we might have a positive linear, and instead of relationship, we use the word correlation. So it looks like there's a positive linear correlation. We're going to work more with this in Chapter 10, but our correlations are measured on a scale between -1 and +1. +1 is a perfect positive correlation, and -1 is a perfect negative correlation. So to give you an idea of what those correlations would look like, a negative correlation, so one on this end of the spectrum, would look something like this, where my dots go down. So if I were to draw a line that kind of goes through that data, it would be, I would have a negative slope. 0, so if I were to look at, these are our correlation coefficients. This is my R value. So if that R value was 0, then I would have no correlation at all. They'd just be scattered. So you can see how those values don't go up or down. They're just kind of scattered. And then we already saw one that was positive. So I'll draw one again, though. So one that was positive might look like this. And if I were to draw a line through that, the line would have a positive slope. So positive. So R would be close to 1. This is no correlation. I'm just going to abbreviate. R would be close to 0. This is a negative linear correlation, and R would be close to -1 because of that negative slope. We really got through the majority of Chapter 2 here. There's probably a few things that we didn't cover, and remember that you've got all of the information in your ebook. If you go through some of the homework questions have some excellent tutorial buttons that you can use, which are not available in the quizzes. But this pretty much finishes all of the material for Chapter 2.